Neutron stars are among the smallest objects in the cosmos, typically just 20 kilometers across. Yet within that tiny sphere exists more mass than our entire sun contains. This contradiction between size and density creates one of the most extreme environments physics allows. When a massive star exhausts its nuclear fuel, its core collapses catastrophically. The collapse is so complete that gravity overwhelms the electromagnetic forces holding atoms together. Electrons are crushed into protons, forming neutrons packed so tightly that a teaspoon of this material would weigh billions of tons on Earth. The surface gravity of a neutron star exceeds Earth's by a factor of 100 billion. Under these conditions, matter stops behaving like anything we recognize. Mountains cannot rise more than a few millimeters before their own weight flattens them. Atoms are compressed into configurations that cannot exist anywhere else in nature. Space itself warps dramatically around the star, bending light and time in measurable ways. If a human body were somehow transported to a neutron star's surface, destruction would be instantaneous and absolute. The tidal forces, the difference in gravitational pull between your head and feet, would stretch you into a thin stream of subatomic particles before your nervous system could register any sensation. This is not death by impact or heat. It is disintegration by geometry, by the shape of space-time itself becoming incompatible with structure. Neutron stars represent a boundary condition in physics. They show us what happens when gravity wins completely, when the forces that give matter its familiar properties are no longer strong enough to resist compression. They are laboratories for studying matter under conditions we cannot reproduce, and they remain stable for billions of years in states that seem impossible. Some neutron stars possess magnetic fields so powerful they qualify as a separate category of object. These magnetars generate fields trillions of times stronger than anything humanity can create, strong enough to alter the fundamental behavior of matter at a distance. The magnetic field of a magnetar is intense enough to distort the shape of atoms themselves. At close range, these fields can strip electrons from their orbits without physical contact, simply by warping the electromagnetic environment. If a magnetar passed within several thousand kilometers of Earth, it would erase every magnetic strip on the planet, disrupt satellite electronics, and potentially alter chemical bonds in ways we cannot predict. At closer distances, the field would begin dismantling matter entirely, pulling apart the structures that allow atoms to exist. Magnetars also experience structural failures called starquakes. The immense magnetic pressure builds up tension in the star's solid crust until it fractures suddenly. When this happens, the star releases a burst of gamma radiation so energetic it can affect planets across galactic distances. In December 2004, a magnetar 50,000 light-years from Earth released a flare that temporarily changed the shape of our ionosphere. For a fraction of a second, a stellar event halfway across the galaxy altered Earth's upper atmosphere. This incident reveals something disturbing about magnetars. They can damage things without sending anything physical. The gamma rays they emit are energetic enough that space itself becomes the delivery mechanism for destruction. Distance provides some protection, but not complete immunity. Magnetars demonstrate that extreme magnetic fields can make proximity irrelevant, that some objects can reach out across the void and change distant matter simply by existing. Near a rotating black hole lies a region where the concept of remaining stationary loses all meaning. This region, called the ergosphere, exists outside the event horizon, but is already dominated by the black hole's rotation. Here, space-time itself is being dragged around the black hole, and everything within this zone must move with it. The effect is called frame dragging. The black hole's rotation pulls space-time into a rotating current, similar to how a stirring spoon creates a swirl in water, except space-time is the thing being stirred. Any object entering the ergosphere cannot remain still relative to the distant universe. There are no stable reference frames that allow for motionlessness. Every particle, every atom, every photon must rotate in the same direction as the black hole itself. This is not a force pushing object sideways. This is geometry making certain states of motion impossible. Inside the ergosphere, the distinction between moving and standing still collapses. The space you would use to define position is itself in motion, carrying everything with it regardless of resistance. The terror of the ergosphere is not destruction, but the loss of autonomy at the most basic level. You are not falling toward the black hole. You are being transported by the structure of space-time, which no longer supports the option of going any other direction. There is no thrust, no engine, no amount of energy that can restore the ability to be stationary. The universe has removed a degree of freedom that we normally take for granted. The ergosphere represents a place where reality enforces motion, where the background structure of space makes certain choices impossible not through force but through geometry itself. The event horizon of a black hole is not a physical surface, it is a boundary in space-time where the definition of escape velocity exceeds the speed of light. Once an object crosses this boundary, returning to the outside universe becomes geometrically impossible, not just difficult. What makes the event horizon truly disturbing is how it creates irreconcilable perspectives. To an outside observer watching something fall toward a black hole, the object appears to slow down asymptotically as it approaches the horizon. Light from the object redshifts, dimming toward invisibility. Time dilation becomes so extreme that the object seems frozen at the boundary, never quite crossing it even after billions of years. From the perspective of the falling object, none of this happens. Time passes normally. The event horizon is crossed at a specific moment with no unusual sensation. There is no barrier, no wall, no sudden change. The journey continues smoothly inward. Both perspectives are equally valid according to general relativity. Physics provides no way to declare one correct and the other illusory. Reality itself becomes observer-dependent in a way that goes beyond measurement uncertainty. Two genuinely incompatible accounts of events coexist, and the universe permits both. This is not a philosophical puzzle. It is a feature of how time and space behave near extreme gravitational fields. The event horizon reveals that reality is not a single objective sequence of events, but something more fragmented. Different observers experience genuinely different realities, and there is no privileged viewpoint that sees the truth. The universe allows its own narrative to contradict itself. Once past the event horizon, space-time becomes even stranger. In some solutions to Einstein's equations, the roles of time and space effectively exchange. The radial direction toward the singularity, which was a spatial dimension outside, becomes time-like inside. The singularity is not a place you move toward, but a moment you move into. This means that falling toward the center of a black hole is not a journey through space, but a progression through time. Just as you cannot stop yourself from moving forward in time outside a black hole, you cannot stop yourself from reaching the singularity inside one. The future literally becomes a location, and that location is the center. Reversing course becomes impossible, not because of insufficient thrust, but because geometry has redefined what reversal means. Escaping the black hole would require moving backward in time, which is as impossible inside the event horizon as it is outside. The path to the singularity is built into the structure of causality itself. Black holes do not destroy matter through force or heat or violence. They enforce outcomes through the architecture of space-time. They turn inevitability into geometry, making certain futures unavoidable not through physics but through the definition of direction itself. This represents a kind of cosmic determinism. Inside a black hole, certain events are not just likely or predicted. They are geometrically required. The universe has structured space-time in a way that removes alternatives completely. According to quantum field theory, the vacuum of space is not empty but filled with fields that define particle masses and fundamental forces. Our universe may exist in what physicists call a false vacuum, a metastable state that appears stable but is not the lowest possible energy configuration. If the vacuum were to decay to its true lowest energy state, the transition would not begin everywhere at once. A bubble of true vacuum would form at some random point in space, then expand outward at the speed of light. The boundary of this bubble would be a moving wall where the laws of physics change. Inside the bubble, the values of fundamental constants could be different. The masses of particles might change, the strengths of forces might shift, chemistry as we know it might not function, atoms might not hold together at all, matter itself could become unstable or impossible. There would be no advance warning. Light travels at the same speed as the expanding bubble, so the first photons from the transition would arrive at Earth at the same moment as the transition itself. No telescope could see it coming, no signal could outrun it. One moment the universe would be normal, and the next moment everything would cease to exist in its current form. The probability of this happening is unknown. It could have already begun somewhere in the distant universe, with the bubble racing toward us through space, or it could never happen if our vacuum is truly stable. Current physics cannot determine which is true. False vacuum decay is not a threat we can prepare for or avoid. It is a possibility woven into the mathematical structure of reality, a reminder that the stability we observe might be temporary on cosmic timescales. Galaxies are not distributed evenly throughout the universe. They cluster along filaments of dark matter, leaving vast regions nearly empty. These cosmic voids can span hundreds of millions of light years, containing only a handful of galaxies or none at all. Inside a deep cosmic void, the environment is profoundly different from our local neighborhood. Gravity provides no structure. Dark energy-dominated expansion occurs without the moderating influence of matter. Motion loses reference points. If you were placed inside such a void, every direction would appear identical. There would be no nearby nearby stars to use as landmarks, no galaxies close enough to show structure. The nearest objects might be so distant that their light takes hundreds of millions of years to arrive, and by the time it does, those objects have moved further away. Time would pass normally, but nothing would change on observable timescales. There would be no new events, no transformations, no evolution. The void would remain a void for epochs longer than complex life has existed on Earth. This is not quite the same as emptiness. It is isolation magnified beyond human scale. It is the experience of being in a universe where you are fundamentally alone, where the clustering of matter has left your region behind, where even light takes geological ages to bring news from anywhere else. Cosmic voids reveal that the universe is not just vast, but structured in ways that create regions of profound separation. They are places where the universe has, through its natural evolution, created conditions of maximum isolation. The expansion of space creates a boundary around every observer called the cosmic event horizon. Because space itself expands, distant galaxies recede from us. The most distant ones recede faster than light can travel through space toward us, and this creates a horizon beyond which events can never influence us. Anything beyond this boundary exists in a region of space-time that will never be in causal contact with Earth, no matter how long we wait. Information, light, and matter from beyond this horizon can never reach us. Every year, as the universe continues its accelerating expansion, more galaxies slip beyond this horizon. They do not disappear suddenly, but gradually redshift and dim until their light can no longer traverse the expanding space between us. These galaxies continue to exist, continuing their evolution, but they are permanently removed from our observable universe. Stars form in those galaxies. Planets may orbit them. Civilizations might emerge. Black holes merge. Supernovae explode. None of it will ever matter to us. Those events occur in a part of reality that is causally disconnected from our location in space-time. The cosmic event horizon reveals something unsettling about the universe's structure. Reality is larger than what any observer can ever interact with. There are regions of existence that will never influence us and that we will never influence. The universe is not just big. It is actively separating into causally isolated regions, and this separation is permanent and irreversible. The universe is slowly running down. Stars fuse hydrogen into helium, converting mass into energy and increasing entropy. Black holes slowly evaporate through Hawking radiation, releasing their mass back into space over timescales longer than the current age of the universe by many orders of magnitude. Eventually, if the current understanding of cosmology is correct, the universe will reach a state called heat death. All stars will burn out. All black holes will evaporate. Energy will be distributed uniformly across space, leaving no gradients, no differences in temperature or density anywhere. In this state, no useful work can be performed. Energy still exists, but it is spread so evenly that no processes can extract it. No chemical reactions occur. No structures form or change. Nothing happens. Time continues, but it becomes meaningless. One moment is identical to the next. There are no events to mark the passage of time, no changes to observe, no evolution of any kind. This is not destruction. It is eternal stagnation. The universe does not end. It persists forever in a state of perfect equilibrium, where existence continues without meaning, without structure, without anything occurring. The terror of heat death is not the cessation of existence, but its purposeless continuation. A universe that exists but does nothing, experiences nothing, changes nothing, time without events, existence without process. A cosmos that has reached its final state and will remain there forever. Heat death represents the ultimate triumph of entropy, where the universe finally exhausts all possibilities for change and settles into a configuration from which nothing can emerge. The most terrifying places in the universe are not hostile, but indifferent, revealing that order and meaning are temporary arrangements in a cosmos that does not require them. If you want to continue exploring where physics becomes an extinction-level force, watch our video on the most lethal objects in space, and subscribe to Cosmic Egg for more journeys to the edge of what reality allows. Thanks for watching.